Hello 108 students, Mr. McCue here. We are going to wrap up section 10.1. We're going to have a little fun here today. I added these to the class notes. You're not going to have any homework problems on this, but a very unique chance to see applied applications of mathematics regarding functions and the one-to-one function capability and the inverse of a one-to-one function. And so if you have your textbooks, if you go to the exercise homework problems at the end of section 10.1, you will see a little machine there called an Enigma machine that was used in World War II, and I'd like to talk about that with you for a couple minutes. So what happened was the Germans invented this machine, and they took the concept of one-to-one functions and inverse functions, and just like we talked back on page page 2 of our notes, if you look in the middle of it, if you took the composition of a function and the inverse function, if you put a value of x into it, like x equals 2, it would boomerang the 2 back to you. And so the Germans were able to write a decoding mechanism to send messages to the front lines to give commands, and the United States and the Allies had a very difficult time countering their moves. And so fortunately for the Allies, a submarine was captured that had this Enigma machine on it, and British and American scientists and engineers and mathematicians worked together to kind of reverse engineer it and figure out how to crack the code. And so let's just take a minute here. I'd like to show some of this concept to you here. A very easy function to use here was linear functions. We could pick one for the day. F of x equals 2x plus 1. Now back we did in our previous notes, we determined the F inverse function of it was x minus 1 divided by 2. Again, real quick, we swapped the x and y variables and isolated for y's. If you go back and look on your notes, you will see that work already done there. Okay, so here's what happened was the sending side would use the function. The receiving end on the front lines would have the inverse function, and the idea then was to very simply take the letters A through Z and maybe assign them numbers 1 through 26. Now you can imagine every day they could use different number assignments for the letters and use different functions up here to make it hard to guess, to decipher or crack the code. But so let's just say today we wanted to write a message, and we're going to use the letters, the numbers 1 through 26 for the letters A through Z, and maybe we would let 0 be representative of a space, so the receiving end can understand what you were saying with spaces in between words. Okay, so here was the concept. Pretty simple. Decide to write a message out. I'd like to send out the message to the receiving end and tell them that math rocks. So you very simply write out the words, put the letters to them, R-O-C-K-S, and then what you did was, now if you look on the in the textbook at the homework that I was telling you about on section 10.1, you'll see a quick table that tells you that the letter M is the number 13. Now A is very easy to see. A would be represented with a 1, T would be a 20, and H would be 8, space would be 0, and you can see rocks was 18, 15, 3, 11, and 19. Okay, so here's what they did. They very simply took those numbers. Now if you just use those numbers, anybody would be able to figure that out without too much difficulty. But if you turn around and took your function, you would take the value of your letter, which is the number 13, you would plug it into the function input. 2 times 13 is 26, plus 1 would produce for you a 27. And this is going to be on your coded message that you send out. So you would just complete this process. There would be a 27. Maybe on the messages you would use dashes here between them, so you would know the numbers were different. If you took the number 1, plugged it into the function, 2 times 1 is 2, plus 1 is 3, then there's your results. Okay, so you work through this, you type up the function numbers, we'll call it, and now you are ready to put that on a piece of paper, maybe use Morse code back in the day. Remember, this was back in the 40s. You sent out this message. The United States was able to pick up those messages, but they just simply didn't understand them, so it was like garbage to them. However, when we did get a hold of the Enigma machine, we were able to do the reverse engineering like I mentioned, and now we started to also receive the messages and interpret them. And here's how you receive them. You would take the numbers that you got, and now you would put them into the inverse function. And so you would take the number 27, it's now in the inverse. You go into the inverse function, which was x minus 1 divided by 2. Put 27 in for x. Minus 1 would be 26 divided by 2, and it would give you the result of 13. Then they knew that the letter 13 corresponded with the letter M, and then they would turn around and start writing the M. And so you could see an application of the number that you put in into the composition of the function. 13 came out of it as a 13, and then they would interpret that as the letter M. Okay, so you could turn around and follow this process here a little bit more. At the receiving end, got the number 3. They would put it into the inverse function. 3 minus 1 is 2. 2 divided by 2 is 1, and then they would know that was the letter A. Okay, so you get the idea, and I'll let you try some of these on your own just to see if you could take the 37, 31, 7, 23, and 29 and reciprocate that with the rocks. Okay, I find this very fascinating, and I just wanted to share it with you. I think in class I like to tease everybody that back in the day when you're in grade school and you wanted to send little love notes back and forth, your big risk was if the teacher would catch you sending notes in class and your students were helping you, you would be embarrassed because the teacher would read that note out. Now you would be able to have the note be intercepted by the teacher, and all he or she would see would be numbers, and she wouldn't know what you were saying. However, your friend would take those coded numbers, decode them back through the inverse function, and would get your message. Okay, that's all for now. Just thought I want to share that with everybody. Thought that was an interesting component of how one-to-one function and the inverse functions can be put to practical use. Okay, that wraps up section 10.1. Page 6, we're done with this section, so I'll be moving on to 10.2. Okay, I'll catch you later.